All right, so today we're going to be talking about Vxlan, which is basically the final conversation what we've been building towards when we've been talking about things like multicast and MPLS and all that kind of thing there. Because you might not know this, but we as network professionals have been at war with STP all this time. STP had its purpose. Already boomerang things. STP had its purpose, but it causes us a lot of issues in the networks, especially in data centers. And the reason for that is because if we have our traditional network where we have a switch 1 and we have a switch 2 and we have one link here and one link there, well, spanning tree's whole job is to block one of these links if, let's say, this is the root. So what we tend to do, we said, okay, well, what we're going to do is we're going to move away from the traditional spanning tree, and Cisco gave us per VLAN spanning tree instead. And this let us say that, hey, this is VLAN 11, and this is VLAN 12, and this guy is the root for that, and this guy is the root for that. And what this means is that this side is blocked on this side, and this side is that, but we still have active-active. But as we go forward, the long story short is we're always going to be blocking at least one link in one direction. Now, for a campus, this isn't really a big deal. Because, a link's a link and it's not a big deal. But in a data center, what if this is a 400 gig link? Keith, do you know how much a 400 gig link goes for?
Oh, in spanning tree?
No, like actual physical cost to buy one?
Oh, I have zero clue.
They are about $25K per side. So if you're spending $50,000 for a connection, you probably want that connection to be always working. So that's where spanning trees started to lose favor in the data center because we always want continuous forwarding. So there's been a few cracks of this over the years. The first one that Cisco did was something called Fabric Path. And this was a relatively short-lived technology that lived on the Nexus 7K. And what it did is it encapsulated the frame in a proprietary format, and it allowed you to route everything through a modified IS to IS, which I believe Kelvin talked about a couple weeks ago. But the issue with this there is it didn't really scale to anything, and it's kind of a tall order to buy a really expensive switch to replace spanning tree everywhere. So that eventually fell by the wayside. And then the industry decided that we're going to instead implement an open standard called Trill. And then promptly all the vendors said, okay, that's great. And no one has actually implemented Trill to any real satisfaction there. The standard came and went and fell like a FUD. No one really uses it in any real capacity. So that went away. So the winner was our topic today, Vxlan. So what is Vxlan? Vxlan takes advantage of our routed infrastructure that Spine Leaf gives us. Because if you remember with Spine Leaf, we have our spine switch, and then we have our leaf switch, And what we do is we have a link. Draw the right. I don't think I did. Good enough, whatever. There and there. So what this gives us is it allows us to have a very predictable network, because to get to any node in the network, it's always going to be 3 hops. If I want to go from here to here, well, it's going up to the spine and it's going down. So it's always going to be that. If I wanted to go to this one instead, well, it's up to here and then it's down to here. It's always predictable. So because everything is predictable, that means that our routing table is all the same. So this means that we can do something called equal cost multipath, which is a very important concept. And basically that just means that the routers are going to load balance the routes as they hit the routing table, because they all have equal cost and the actual router doesn't care what destination it comes from. So because this is a routed topology, what we need to do is we need to take our layer 2 and we need to encapsulate it in a UDP packet. And that is going to be under 4789 for the port, if you ever take a test. And then what they do is they send this UDP packet across the network through, and then on the other side. So what this process is called a VTEP, Virtual Tunnel Endpoint. And then on the other side, we have a VTEP. And the VTEP, all it does is it encapsulates and decapsulates the Vxlan, and then it drops it off on the actual destination. So this is kind of similar to the MPLS that we talked about the other week, because instead of putting a label on it there, we're just encapsulating the packet as UDP, and we're sending across the network. The difference between MPLS is that MPLS had to be running everywhere, and we had to do a lot of considerations. With this, we're just sending a regular UDP packet there, and no one really knows any different until it gets to its destination. Now, let's clear up some space here. Before we get into the fun part, let's just finish up our theory. So, the overhead for this is 54 bytes. So what this means is that we're going to have, I believe it is 18 bytes for the inner, and this is going to be like your VLAN ID and all that kind of stuff, your MAC address. And then it is going to be 20 bytes for the outside. And this is just going to be your outer destination stuff. And then the actual UDP header is going to be 8 bytes. Now, the biggest thing that you need to know about this, unless you take a certification exam, of course, is that if your MTU is 1500 by default, you need to add 54 bytes onto it there. So you have 2 choices. One is you lower it, so you make this a 1400, and then you can do it there. But the more common thing for a data center network is you want to raise it. So you want to do at least 1600. And most of the time we go all the way up to a jumbo frame, which is typically 9216, depending on your platform. And then this gives us the most flexibility and efficiency. Now, some platforms like VMware, they prefer 1600 for their platform there, but it doesn't really matter as long as all the bits fit inside the frame. Everything make sense so far?
That's affirmative. Thank you.
Okay, cool. All right, so what I've done is I built a topology that will look scary, but it's not as bad as it looks. So this is my CML. And what we have here is we have our spine leaf architecture, and it just looks scary because I have a management node in here. So we have our spine, and then each spine has exactly one connection to each leaf switch. And then vice versa there, and this is how we get our ECMP there, because we're not treating any node differently there. And the way this works is that if we need more ports, we add a leaf, and if we need more bandwidth, we add more spines there, and that's going to add more paths for our ECMP. And then all I have here, let's just clean this up a bit, is I have a management node, and this is just for me to do my provisioning stuff, so don't worry too much about that. This is just connected to the management ports. And then what we have is we have a server, 4 servers, and they are all going to be in VLAN 1, 2, 3 in the end. You might be wondering why I didn't do 1, 2, 3, 4, and I just didn't think of it at the time. But we're going to be setting up this, and then what we're going to do is we need to embed this VLAN into the Vxlan using something called a VNI, a Virtual Network Identifier. And this is going to give us a lot more flexibility, because if you remember, how many VLANs do we have? We have 4,096 total VLANs. Counting from 0. So that means that that sounds like a lot, but if you take your average switch, how many VLANs can you actually provision? You can usually provision about 100 depending on how powerful your switch is. And then from there you have various other considerations there. So usually you're not getting anywhere close to 4,000 VLANs there, and if you wanted to do something like have a truly isolated workflow, that's a big problem. So with Vxlan, with the identifier, what we're doing is we're taking this VLAN tag and we're correlating it to the VNI, and this gives us 16.7 million identifiers. So that is enough to do practically any kind of lab you want to think of there, and that's enough for pretty much most providers. I won't say it's enough for everything there, because we'll always find a way to run out, but it's definitely a much better start than it typically is.
Quick question?
Yep, go for it.
Is there the same kind of limitations on the hardware in terms of like the 100 or so that you can have for the VNIs?
No. So basically the VNI has no practical limit. There is, on certain devices, a hardware VTEP, which basically means that it uses the hardware for forwarding. But practically, you're not going to hit any real limitation there unless you're doing a real one there. And if you are, then that's going to push you to things like ACI for an SDN solution. Because all your SDN solutions really are is they are Vxlan orchestrators. They just make it easy to put the solution together for you. Anyway, that is what we're going to be doing. And then I also have added a switch here. And what we're going to be doing is we're going to be having a quick look at something called virtual port channel and how that interacts with Vxlan. The thing I haven't quite talked about yet before we dive into it there is that in this lab, this is the Nexus platform. This is Cisco's data center class switch. And this is a little bit different than what you might used to if you just worked on traditional CCNA stuff with the iOS. So we'll point out some of the differences as we go. And we'll also look at some of the features and whatnot. Now, I can do this in pretty much any platform. I could do this on Cisco routers. I can do this on switches. I can do this on the ASA platform. I can do this on SD-WAN. I can do this on ACI, like I mentioned, and I can do this on things like the DNA Center, which is their enterprise SDN on the CCNA. I can't do this on Firepower yet, but I imagine that's coming. But
when you say this, you mean
Vxlan. So basically, my point is that practically every platform supports it there, and not just Cisco, by the way. Palo Alto, Fortinet, HP, Aruba, basically all your vendors support some kind of Vxlan. The only one that moved away from it is VMware. They decided to back a tunneling solution called Vrf, and it is essentially like Vxlan, but it is supposed to give them more control, but it has less hardware support. So I kind of think that's really a bad idea, but what can you do? But anyway, so basically this is in their NSX platform, which is their SDN. Their T supports the Genvir, and the old NSX-V is Vxlan. So this is opening up a whole new world once you get the processor. I chose to stick with Nexus Air because it's a little bit easier to put all the bits together than on a router, and it's a good way to expose you to a new platform rather than doing the same old steps there. So that's why I picked the Nexus for this. So with that, I'm going to clear my screen, and I'm going to open up my CRT. All right, so this is my Nexus switch. I have basically all of them connected. We're probably just going to be working on the two spines and the two leaves. We're probably not going to touch the other leaves unless we think of it, but they're there. And then I have also pre-configured the servers to run on the 123 network I mentioned. And then I just did that with a simple net plan. So basically I just had the static IPs there, and I didn't really do anything else. So let's just go for the basic setup on the spine switch. So we're going to set the host name. And we can set the domain just like we would before. We don't really need the domain, but I'm setting it just because. And then we can start actually configuring our interfaces. So if we look, the syntax is pretty much what you would expect. So I can do my IP status there, and we can see that we have a bunch of interfaces. So if I go here, we can go no switch port, because we want this to be a layer 3, remember? And we're going to go ahead and enter in the IP. Now, this is the first difference, is that we can do / notification on Nexus. We don't have to do the network mask if we don't want to. And we're going to no shut. And we're just going to go in through that for all the other interfaces. So we're just going to say actually, you know what? We're just going to do this. I really do like the notepad functionality on Secure CRT. It makes this a little bit easier. And then we're going to add a loopback. So this is just going to be 255.1/32, and we'll no shut. We're also going to make sure our logging is on. And if we do a show IP interface brief, we have our links up. So the next major difference of Nexus is that it's very hardware and performance focused there. So all the features that are available by default by iOS there are turned off by default. So if I wanted to configure OSPF, I can't. And the reason why is because I have to enable it as a feature. So if I look, there are quite a few features here. I can see things like if I wanted to enable BGP, which we'll be doing later on, we could do OSPF and so on and so forth. But even things like SVIs, we need to enable the interface VLAN there. This is in part for two reasons. One is that because Nexus is so performance focused there, it's literally just not having the features available if you don't need them. And two is that it also helps your security posture there if you literally don't have any enable commands, because if there's a vulnerability in OSPF and you're not enabled, you're not going to have any issues. So we're going to go ahead and we're going to turn on a few features that we're going to need. We're going to need PIM for multicast. And you can see here that it's going to tell us that we need an enterprise there, but it's basically using an honor-based license, so that's just going to work. So it's one nice thing about the Nexus platform for labs is that you don't have to chase licenses, it's just going to trust you. And then we're going to turn on OSPF, and we'll leave it at that for the moment. So what we're going to do is we're first going to enable OSPF. So we're just going to say router OSPF. And what we do is we actually give this a process tag. Instead, normally we would just type OSPF1, but we can actually give this a name. So I could say something like meowcat. And normally you would think I would type my network statement, but we don't do that on Nexus platform. It's exclusively interfaces. So what we do is we would enter in a range, and we would say IP router OSPF. And then we type in meowcat, and we enter in our area like normal. So we're just going to put everything in area 0. We're not really caring about the underlay too much. And we will also do that for the loopback. And what we're just going to do is just carry forward and do the same thing for the other ones there. Now, I should have configured the IPs already, so we're just going to go feature OSPF. In fact, I'm just going to save some time here, and we're just going to go feature PIM, feature OSPF, and then we're just going to say IP router OSPF meowcat. And then we'll do that for a loopback. And then we actually need to enable the process. So we're just going to take this again. So if I did that right, we should start seeing OSPF come up. And while we're waiting, we're going to do a couple other things. We're going to say that the system jumbo MTU is going to be the highest one, because remember we said we were raising the MTU here. And then we're just going to say int 14, and we're just going to say MTU 9216. So basically we're just raising the MTU on all the interfaces. We're going to copy this and just do this on our switches here. Alright, so our OSPF is up. If I check our routing table, can see that this looks a lot different than what you used to with iOS there, but we have the same basic idea. We can see that we have our loopbacks, and we are seeing that we have one loopback per leaf switch, which is what we want. So next was what we need, or the next thing we need is multicast, because when we are doing Vxlan, we need to transport the traffic somehow. So we basically have few choices. We have to do multicast, which is what we're going to be doing. We can do static, which means that we statically point it to the other VTip and tell it where to go. If there's time, we might look at this there, but typically you don't use this option. And then lastly, we're going to look at BGP. Oh, wrote that terribly. Let's try that again. BGP.
Would you be able to avoid the enterprise license?
No, I don't believe so, because I believe the actual Vxlan feature uses the enterprise license.
So no matter what.
Yeah, but again, it is an honor-based license, so unless you're doing this for the real world, you don't really need to worry about the pricing. And this is good.
Honor-based isn't. It's not just not package CML. It's like the real world too.
Yeah. But of course, if in the real world you do have to buy it, otherwise you're gonna wind up in some problems eventually. But if you're doing an implementation, you don't need to worry about the licenses right out of the gate. And this is going to be something called EVPN, which we'll talk about towards the end of the day. All right, so we'll clear that out. And what we'll do is we're going to start setting up the multicast. Now, on a router, we would do IP multicast routing, but we don't have to do that on Nexus because we've already enabled the feature, so it knows that it's doing multicast routing already. So what we need to do is we need to set up our RP, and we can do this a couple different ways. Now, if we look at our topology here, our point is that we want active-active forwarding. So if we do something like BSR, that's fine, but it's going to prefer one switch over the other. And that's not necessarily what we want. So what we're going to do instead is we're going to do Anycast. You can see how all these topics kind of build up to this from when we talked about all this other lections earlier. What we're going to do is use Anycast for the RP address, which means that we're going to advertise the same IP address on both switches there, and then the leaves are just it's not going to matter which one it uses. So we're going to go back to our configuration. And what we're going to say is IP. First of all, we're going to create an interface. So we're going to say add another loopback, and we're just going to call this 192.168.10/32, and we'll go to description one out. We'll say this is Anycast RP, and we're going to put this into OSPF. So I'm just going to grab that. And paste that in the other spine. So now if we look at the leaf switch, we see that we are learning that from both spines, just like any other route. Of course, we need to do more. First thing we need to do is we need to enable PIM on everything. So we're just going to say is interface 1 through 4 is going to be IP PIM sparse mode. By the way, the Nexus doesn't support dense mode there because it's all about high efficiency forwarding, so it doesn't use the legacy stuff. And then what we're going to do is we're also going to put that on the loopback we created so it can be an RP. So first what we need to do is we need to tell it that this is an Anycast IP. So we go IP pim, Anycast RP, and we give it the IP address of what we're doing. So it's going to be .10. And then we tell it the IPs that are going to be in it. So this is going to be 255.1, which is spine 1, and 2, which is spine 2. So now that's defined, we can go ahead and go IP pim RP address. And we can just say that this is the RP address. Now I can do more, but what we're going to do is just say group list. And we're going to tell it that this is just going to be for the private range. So I'm going to grab my history again. And we're just going to grab this section. And we're going to paste that here. Then I just need to grab the static RP. And we're just going to put this on all the leaves here. We can do more fancy things, but multicast really isn't the point of this. And if we go show IP pim RP, we see that it is happy and we don't need to worry about anything. Okay, so at this point we have our routing up and we should have our pim up. So if I go IP mroute, we don't have anything advertised yet, so that's fine. And if I go pim neighbor, we see that we are neighbored to all the switches. And if I go show IP pim neighbor, same thing here. So that's looking pretty good. So now we actually have to start building our Vxlan. So on the spines, we don't really do anything because the point of the spines is just to forward the traffic, so we don't need to worry. So on the leaf, we're just going to leaf 1. And we first need to enable the feature, and that is NV overlay. Now what we need is, we also need one other feature, and that is VN segment VLAN based, and this is the VNI I mentioned earlier, the VNI, the virtual network identifier. And this is how we actually tag the traffic as a Vxlan. And then the actual overlay is what's enabling the feature called the NVE, which is the VTEP. All right, so. Yep. Did I hear something? No, guess not. Okay. All right, so what we want to do is we first want to create our VNI segment. So we're just going to say VLAN 123 is what I said. And we can give this a name. So we can say name, we'll call it Vxlan LAN01, whatever. And normally we would be done and we configure a VLAN, but instead what we do is we go VN segment. And we tell it a segment there. So remember I said there's up to 16.7 million. So what I like to do in labs anyway is I like to do 1000 and then the VLAN ID. So 123. And that just helps me as a naming standard, but you can use whatever you want there. So now what we're saying is VLAN 123 is now going to be tied to VN segment 1000123. So I guess that would be 1,123,000. And that's going to let us reference that in our configuration as we move forward. So the actual Vxlan configuration is pretty simple. So what we do is first we want to go to our interface where we have our server configured, and we're just going to say that this is a switch port, and we're just going to put this as an access port, and we're just going to put that in VLAN 123. And from this port down, everything is running on spanning tree, and we don't need to worry about it, but the spanning tree dies at this port. So it's basically we're not extending our layer 2 there, we're just having it on each individual port that's running this. So that's all we need to do here. Let's give a description, S01. And now what we do is we configure the NVE virtual interface. Now there's only one allowed on the system, at least on Cisco's, because this is the master configuration for your VTEP. So we're just going to go 1 here. And it is going to give us a bunch of options here, but the main one that we want is the source interface, and then we want to tell it the members. So we're just going to say source interface is going to be loopback 0, and then what we're going to say is the member is the VNI. This is why I like to have predictable names there, because I want to look back and forth. But we can enter in ranges here. We can do whatever we want. You do have to define the VNI here individually there, and this is why orchestrators like DNA Center or Data Center Network Manager are a good idea, because they help you keep track of all these little configuration tidbits. But inside here, this is where we can say that we want to do either static, which is where we just say, hey, this is static. Or what we would do instead is we're going to say that this is a multicast. And we pick a prefix. So I'm just going to say 255, I don't know, 100, 123, doesn't really matter. So what we're saying here is that for this VNI traffic, we are going to send out a multicast on this group, and then anyone who hears that is going to be discovered for the VTEP. So, of course, you do have to no-shut this there. I've been burned on that a few times. I was like, why isn't this working? And, of course, the interface is down. So make sure you turn that on. And at this point, that's all we need to do on this switch for this phase configuration. So what we're going to do is hop over to 2, and we're going to basically just do the same thing. We're just going to say show CLI history. Copy this. And copy this. By the way, if you're doing more complex labs there's no shame in copying, pasting, or using Notepad to make your life easier there, because you will spend countless hours troubleshooting a small typo when you accidentally type like the wrong IP address or VNI or something. So we're going to go paste here. And then we're just going to go port here, switch port access, VLAN 123, switch port node access, description is going to be server 2. And no shut if it's off. So at this point, if I check our multicast, we can see that we have our loop back, and it is joined to this group. And if I look over here, we have this loop back joining for this group. So now we're just got to actually generate some traffic. So what we're going to do is we're just going to say on this side, we're going to ping (102), and on this side we'll ping 101 to help it along. So this might take a minute there, and while it's talking, I'm just going to draw this out. So there's basically what we're doing here is we are using something called the flood method here. And what this is actually called is the flood and learn. So what we're doing is we're basically just flooding out the traffic across the multicast. The other side should eventually learn it, and then once it does there, it's going to discover the VTEP there, and eventually this ping is going to start working. So if we look here, While we're waiting, any questions?
I have several.
Sure.
Yeah, I've done this before, so I kind of have the 30,000-foot view, but I'm maybe looking for a bit of clarification on a few things. So my understanding is that just if you had like a lot more switches involved, the idea is that you're doing like a local VLAN mapping to like a global VNI, right?
Yep.
Okay, so now you mentioned before that some switches and platforms have limitations of like maybe 100 VLANs
Mm-hmm.
per switch. Now, would that not mean that even though you have like 16 million VNIs, you're still kind of limited to 100 mappings per switch?
Technically, yes. So if you're, you can basically, the idea is that your per switch is still going to be down. Like if you actually need 100 if you actually need more than 100 VLANs on a access switch, that can be an issue. But the practical scalability is that if this switch is 100 VLANs, let's just say, and this switch is 100 VLANs, each one of these can use unique VNIs, so that the actual outer VLAN doesn't really need to match. It's really just the transport side. So basically, this is how you scale there, because each switch is basically the VLAN becomes locally significant, and it's only the VNI you care about. Make sense?
Yeah.
Cool.
And just to clarify, the whole point of the multicast in this specific case is that you're trying, if you had like thousands and thousands of switches, you're not basically avoiding broadcasting everything by using multicast to subscribe different VNIs to different switches so that it's efficient, right?
Yeah.
You get the whole multicast or equal cost multipath thing.
Yeah, exactly. Let's see if I can speed this up a bit. Yeah, this is one of the reasons why the next thing we're going to talk about, EVPN, is more efficient there, because the flood and learn is basically works. It's just like with the dance mode multicast. It takes however long it takes to actually learn, and then it can cause some issues there. So what we're going to do is is okay, you're learning it, but you're not getting it from the second one. So to speed this up, what I'm going to do is just switch this over to BSR, just so it goes to one spine there. We don't need to worry about too much. So we're just going to say is IP candidate is going to be loopback.
Would you have to run MSDP between your Anycast RPs in that case? Then actually just come to G's there.
Yeah, actually, let's do that instead. That sounds more fun. That's a feature. Why not?
Have we ever done a demo that involved MSDP panel?
No, so this is the lucky first. Hmm?
I want to explain what MSDP does.
Oh yeah. So basically, what we're doing here is this is what I get for changing my lab at the last minute here. But we have two RPs running as Anycast, but the issue here is that this isn't really talking with this one there to share when the leaves join. So when this guy says, hey, I'm joining this group, and this guy says, hey, I'm joining this group there's not really any synergy going on.
Like a split brain kind of thing.
Yeah, I was waiting for a bit because usually what would happen is they eventually would naturally solve the problem by just talking through there. But to help things along, we're setting up something called MSDP. And what this is going to do is it's just going to share the database essentially between the two RPs so that they're aware of what happens. And it adds a little bit of fun to our lab, so why not?
Can you explain what the acronym stands for at least?
Source Discovery Protocol.
No, he beat me to it.
Yeah, cool. I kind of figured Discovery Protocol, but I was wondering what the other.
Fair enough. So it's going to be 2. Connect source is going to be loopback 0. Then on the other side, we do IP MSD here. So we should see in a second. We're going to stop this for a second. Oops. When you try and stop typing there, but it adds more effort than you expect. All right, so we'll give this another 30 seconds, and I'll just put it to BSR instead. All right, whatever. So what we're going to do is we're just going to enter in some commands here because BSR traffic is not forwarded by default, so we have to tell the Nexus they care. And then what we're going to do is we're just going to say IP BSR candidate loopback 0, and we're just going to say that's fine. And RP candidate group is going to be and if we go here,
So are you getting rid of Anycast?
I am. It's just it's adding extra complexity for it. And it's kind of derailing. It's derailing what I was hoping to show. So I'm just gonna moving it to BSR so that the actual multicast is nice and predictable. So if I go show IP PMRP, By the way, if you use Nexus there, you need quotes when you do spaces. Very annoying. And then here.
Curious, do they let you backslash to escape a space? Any case like that?
Yeah, I believe so. Wait, you mean like show IP? Oh, like show IP include. Oh, you mean like
Yeah, like a backslash space. Without no. No, if you do no quotes but IPs backslash space and then route.
Well, then regex is actually underscore. But the regex on Nexus is a bit more defined or strict than it is for.
But it's not a regex. It's like.
Yeah, I know what you're trying to say. Like you're trying to do like a.
But the include is using a regex.
Yeah, that. Yeah, well, so if I do that without, yeah, so basically the it's actually passing this string there. It's just iOS is very I don't really care and just gonna pass everything there. Nexus is very strict and defined.
I just curious because in like a Unix shell, typically you could get around the quotes with a backspace or an escape.
Yeah.
Backslash.
All right, so there's our RP. So let's just see if that fixed our issue. All right, there we go. So we can see that 1 and 2 are learned. So let's go back to here and we'll get back on track. So what we should see is eventually the peer on the other side should be learned. Now my testing does take a little bit. That's a really annoying thing. So what we'll do is we'll just run this on another tab here. Yeah, we'll just wait a minute. Yeah, while we're waiting, we'll clean up this stuff too. Let's see if we can open the long. right. Well, I'll start talking about EVPN, and then we'll come back to this. This will work itself out. So as we're currently seeing with the classic Vxlan, is that it's a little bit clunky because the topology needs to flood everything, and it's only going to learn to appear when this host starts talking, and this host starts talking, and eventually the multicast talks enough there so that the VTEPs are discovered on each switch. So because of that, it doesn't really scale very much there. So if we have 2 switches, you can see it's being a bit annoying there. But if we have 100 switches, that's going to be a really unacceptable way of scaling, because basically you're having to broadcast across all the switches to hear it, or at least multicast. So the way they handle it is they use a reliable transport called BGP. And what this will do is this is going to advertise all the host reachability stuff. And then that way that all the leafs there, if we have a bunch of them, like leaf, is they're all going to be on the same page about where things are. Now, there's certain types of traffic that will still go for the multicast, and that is called BUM. So this is broadcast unknown unicast, and of course multicast. So this traffic is still going to go through the multicast fabric there, but everything else is going to go for the BGP, and what we call this is EVPN. And what we do is we configure BGP on all our routers, including the spines. The spines will be route reflectors, so they're going to help us consolidate our peering, so all the leaves just peer to the spine and get all their routes. And then all the policy stuff remains on the leaves there, and the spine, they just transfer the traffic. They don't really care what it is. So if we get back to here, I'm just going to try this real quick. I'm just going to shut. No shut. And no shut. All right, we'll come back to it later. So let's just get started working on this there. Basically what we would have seen if the flooding worked. Of course, I tested this last night and Murphy's Law and whatnot, but what would have happened here is that we just would have saw this pinging, and then we would have gone through there, but there's more verification on the EVPN anyway. So the first thing we need to do is on the spine, we need to enable BGP. And in fact, we will do that on all the routers or switches. And then on the spine, we don't need to enable anything except for we have this command nv overlay evpn. And what this does is just enables the address family in BGP for us. So what we're going to say is router BGP 65123, just a private AS number. Then we're going to say we're going to enable the L2 VPN EVPN family. And we're going to create some templates. So we're just going to say that we're going to create a peer session. And we'll call this Vxlan session. And the template just lets us store configuration items that we need. So we're just going to say that we want the remote AS to be 65123. We're doing IBGP. And then we're doing update source. We'll say it's feedback 0. And then what we're going to do is we are going to create another one called policy, and we'll call it Vxlan policy. And here we're just going to say that this is going to be a route reflector client, and we are also going to send the communities. So that's all we need for the spine. Of course, we actually need to create our neighbors. So what we're going to do is we're going to say that's what I thought there. What we're going to do is we're just going to say, yep.
So in production, would you use something like dynamic neighbors on the spines? You
could, yep. That would actually be a pretty good idea for that there, but trying to keep it somewhat simple-ish. Yeah, a dynamic neighbor would be a good idea, especially if you're scaling a lot. Either that, or you would just rely entirely on automation to add the peers as you go. And we'll say address family is L2 EVPN, and then we'll say inherit peer policy, Vxlan policy, and 10. All right, so if I go show run section router, we now have this skeleton. So what I'm just going to do is just say 12, 13, and 14. So if we look at the whole thing, we now have a relatively clean BGP thing there because we're using templates for everything there. So this is going to be very easy for us to modify and stuff if we need to. So we're just going to go here, and we're going to put this on the spine as well. Oh, I forgot to enable the feature first, so overlay EVPN. It's good to show you there that the Nexus literally won't have the commands if you mess up there, so it's pretty good to realize you forgot a feature or something like that. So I'll paste that again. There we go. And while we're here, we're just going to say no loopback 1, no loopback 1. And then for the leaves, what we're going to do is we're just going to go same thing. We're going to say overlay EVPN. And we do not want it to be route reflector, so we'll take that part out. And we only need 2 sessions because we're going to the leaves, so it's fine. So 1 and 2. So we're going to copy this. And we're just going to paste that. And we're just going to paste that on all the leaf switches. So once again, notepads are your friend. So give that a second, and we should see show BGP L2 VPN summary. So we can see we have all but one up. Okay, they're all up. So at this point, our spines are configured. All we did is add the BGP. And on the leaves, all we need to do is we need to add some extra configuration here. And we do that by going EVPN. And then what we do is we say that the VNI, which was 100123, this is a layer 2 VNI. By the way, just so we mentioned there, we're talking about layer 2 Vxlan. Maybe next time if we continue this topic, we'll talk about layer 3 Vxlan. And what this does is this lets you exit the Vxlan gateway so that it can get onto the internet. So this is similar to doing like an internet service or whatnot for your MPLS. But we're probably not going to get there today.
Cool.
But so all we do here is we tell it some settings. So remember from the input out selection, we have to make route distinguishers and whatnot. So before we typed it in, but Nexus has a handy feature called auto where it figures it out for us. And then what we're going to do is we're just going to say route target, both, and just auto. Now it always gives you this warning there that it can't generate it, but it works itself out, so don't worry about it. But at this point, we have EVPN set up, so we're just going to do is go EVPN. And that's good enough for now. So if I go show BGP L2 EVPN, we don't have any routes yet. Because this is still causing us some grief. So what we're going to do is what I'm going to do is we're just going to delete this. And we're going to re-add it. And what we should eventually see is we will start seeing traffic from this being learned on here and advertised to the other side. Oh, I forgot one little critical detail. I forgot to tell the VTEP that it is running EVPN. So we go host reachability. BGP. You knew you actually had to configure things correctly for them to work, right? So this is where you tell whether it's learning the protocol. So BGP means EVPN. Controller you typically won't use, but that's typically something like DNA Center. And then OpenFlow is kind of more of the open source SDN that kind of failed, but it's still around for certain capabilities. So what we're going to do is go to the other side, and we're just going to say host reachability is BGP. So now we do that, we can start to see that it is learning. So this is a bit different from what we normally see there, but what we can see is that it's generated a route distinguisher for us, and then it is actually advertising the MAC address instead of the normal stuff there, as well as the next hop and such there. So this whole prefix is what's being advertised, and then it's saying to get there, go to leaf 2. And we can see here that it has learned the first one. And if I do my show MV peer, we can see that we finally learned the peer. And everything is looking good there. So we can see that it is learning from the control plane. That's what CP means. If we had it working in the first part of the demo, this would be data plane instead, but that's really the only difference. Now if I look here, don't quite have it pinging yet, but eventually we should see that start to learn. So let's go up a bunch of times. So again, we see that we are learning this and that. If I go show L2 VPN or route MAC IP all, hasn't quite come through yet. Let me just actually check those ports, make sure they're actually looking good. 5. Okay. So what we should start seeing eventually is the ping will start being successful because our BGP is working. And if I do a show IP mroute, so our multicast is still buggered. Let me have a quick look at this. Show run include pim. Okay, so we are saying candidate. RP candidate loopback 0 for listen. Yeah. That's fine. Starting BSR. Is refusing. Okay, so that's working fine. You know what? Let me just do this. One sec. Just gonna say VLAN 101. We're just gonna say 101. And let's say this is okay. And then let me go. Like so. I think my issue is my actual spine, or my leaf switch is having an issue. Let me just try moving this to another one. The CML is great, but sometimes when you do the more advanced labs, it gets a little bit cranky if you do some prep there. So let me just do this real quick.
I've noticed the same too, like to the point where I've had to actually reload switches and then the problems go away.
Yeah, the issue is with the Nexus there, I'm using a custom image and it sometimes has some bad juju. So let me just do this.
The CML fabric isn't fully compatible with NX10.
Yeah, well, I am using 10 there, and I tested it last night, but I think when I tested it, I cleared it out there, but I think I might have, because everything's working fine except for Leaf 2. So let me just go feature, overlay. So what we're going to do is we're going to say and then we're going to grab for the most part, we're just going to do the same thing here. Feature, overlay. Grab this. Let's grab that. And let's grab all right, so if nothing else, we should start to see switchboard access VLAN 1, no shut, and switchboard access. If nothing else, we're getting more routes in here. So you can see that we are learning the EVPN routes. So let me try ping yourself, can ping the other. Ping yourself, can ping. Alright, so if I go show NB peer, we can see that we're learning the peers for the control plane right enough. And if we look here, everything is joined. Yeah, so I'm likely hitting a platform thing. We'll just see if we can work around it. We're having fun anyway.
So you're saying BGP is the control plane in this case, right?
Yeah, that's the point of EVPN. So
What's the E stand for?
extend or Ethernet VPN.
Oh, cool.
Basically, this is the new rage in pretty much any new design for campus and data center, because it when you have your computers, well, you
and I'm assuming this is routed access, I guess, right?
pretty much, yeah. So instead of having VLANs, you can just terminate each of these to their own little VNI, and then you don't have a spanning tree past your port here. So you don't need to worry about which is switches root and that kind of stuff. And when you do things like SD access, what it's doing, well, it's doing a lot of things, but what it's doing is it is taking your computer on your switch port, and it is encapsulating it here as a Vxlan, and then it's sending it over to the ICE server so it can do its security posture for the TrustSec. And this is a huge win because ordinarily for TrustSec you need to have end-to-end connectivity there, which meant that if you had like lower switches, you couldn't really do anything, right? Because you had to buy a decent level switch there to have TrustSec end-to-end. But with this, you encapsulate it, send it to the ICE for its decision, and then it enforces the TrustSec right down to your access port servers. That's why SD access is a really hot item right now, because it helps you do what they call intent-based networking. And the idea is that you're just telling it, I don't really care how you do it. I just want marketing to be able to talk to HR, and you just have ICE figure it out for you. So, let's just see if that helped any.
Oh yeah, I'm curious, is this available only on Nexus switches, or is this also available on Catalyst series?
On the new Catalyst for sure, like the iOS XE, like the 9 case.
Oh.
Older ones, not so much. But basically all the new gen stuff supports it.
Darn. I wanted to lab it up with physical equipment.
You can always buy a CML.
Already did that.
Well, there you go. Alright, so... this is
I kind of wanted to lab it up and throw it into production here in my environment.
Good times. Alright, we're just going to cover one last thing here, and then we'll just see where it goes there. But the other thing to point out is... You see this error message here about you need to do something called TCAM carving. Fine, make me scroll again. Here. This error message here. This is basically showing you something about TCAM carving, and the idea with Nexus there is they're very highly hardware flexible. So the idea is that when you have a Catalyst switch, you have like your SDN profiles to configure how you want to allocate resources, but with the Nexus, you can do it very granularly. So you do that by creating these hardware access lists. So if I do show hardware TCAM access list TCAM region, this shows you how it's allocated all its different things there. And what this is saying is that we need to let the ARP have a larger slice of the pie. So we do this just by saying hardware access list TCAM region, and then we pick what we want. So I just pick our ACL, And then we'll say that this is going to be lowered down to 256. And then what we're going to do is for the ARP, we're going to say that this is going to have 256, and we need something called double wide, which means that it takes a larger slice. So if I do that for each thing here, so I'm just going to say like so. It's going to tell us that we need to reboot the actual servers there. No, we're actually going to reboot it there because these are virtual and don't really need to do this. But on hardware, you're going to have to pay attention to what your TCAM is, and you're going to have to potentially make difficult decisions about how you want the switch to allocate its resources. So we're just going to go ahead and say copy around start. And then the last thing I'll show you there, we're not going to bother about the successful ping. Everything else is fine. I'm just having a weird multicast bug. Is that... actually, let me try to take multicast out of the equation. 1 second here. Let me do this. Before I give up, we're going to disable multicast. And we're going to do that by going under here. And we're going to say no. And then we're going to say that the ingress replication is BGP. Because you can do this with Unicast as well, aside from multicast. It's just not necessarily as pretty. But it can get you out of some binds there. So what we're going to do is we're just going to say V1, shut down. And then no shut. Comes back on, it should try doing BGP for the replication instead of doing the multicast there.
Hey Donald, while you're waiting for that,
Mm-hmm.
I really like your secure CRT colors. What theme are you using?
It's actually a custom one, so I found the what am I going to? I'm going to
Default session, I'll do it, I think.
Yep, actually session op should be good enough. There we go. And if I go to highlighting, so I found this God knows where, but it's Cisco words for blackboard or black background.
Yep, I think I got that. And then if you click on appearance, what theme are you using behind it with that?
And then I usually use traditional. And then basically what I've done there is I've used this and I've customized it as I needed to. But basically this provides all the basic regexes. I can send this to you later, Keith, or put on the share for everyone. It
just looks really good. Because I have the keywords and I thought, man, this looks better than what I've seen. So thank you for that.
Alright, so let's just see. Is this back up? Apparently so. If this doesn't work, I'll just move on, but accept my immutable issue. But if I go to here, Oh, okay, so this guy's working. So 3 and 4 are working now. Because basically I was having a multicast issue at one point. Oh, wait a minute. I never took off MSDP. Let me just try something here. I'm curious. I'm just going to go no feature MSDP. No feature MSDP. But this is what we're trying to get to there. So you see how the ping is working even though they're on different leaf switches. So where's my topology here? So we have a ping working on the same subnet from this guy to this guy. And they're directly connected as far as they're concerned. Because this is all routed. And I don't know why I'm writing in pink now, but it wasn't an International Women's Day the other day, so perfect. But that is good. So what I just want to do is I forgot when I was getting the Anycast going, I had MSDP enable, which shares the databases, and I was wondering if that's causing an issue. So what we're going to do is we're going to go back. And we're just going to say, actually, I don't need to change anything. I just need to put this VLAN back to 123. No, okay, so that's something else. But if I go show L2 route MAC IP all, I don't see it anymore. But we would have just saw the actual IP information. But okay, fair enough. I accept there's an unsolvable multicast issue going on. But that is basically EVPN working. If I put this back to VLAN 101, this should start working again because it was working up here. Might need to give that a minute, but what I'm going to do just real quick is I'm just going to finish up the last part of this. So the other way you can go is if you open up Data Center Network Manager. This is a way that can handle controlling your fabric in a more logical fashion, because otherwise you're going to lose track of your VNIs and all that other stuff. So I've already added the switches. Except for I might not have added spine 1. Let me check here. No, okay. So I'm just going to go Vrf Context Management. And then we're just going to say IP route like so. And then management is going to be this guy here. And eventually, but basically what this does is this lets us build out our fabric as we need to. If I go to Fabric Builder, it's going to help me make decisions about my network there. So if I go Fabric Settings, it's going to let us apply various templates there. So we can see like, okay, what mask do you want for your connections? Do you want to use OSPF or IS to IS, or do you want to do some other features I haven't talked about? And then it can configure the VPC stuff. It can also do basically all the routing bits and bobs you want. And when you're done, you just go save. And we can go save and deploy. And we're not going to actually go through all this other way. It's probably going to fail. But what this will do is this will essentially, it's going to reboot all the switches, and then it's going to use something called zero-touch provisioning, or POPE, to actually configure the switches. Essentially what it does is it sends the configuration to the switch through a DHP file, and then it provisions it. And once in here, it has all the configuration that you add in here for the templates, and you can manage it. So for example, if I wanted to do, if I wanted to control the interfaces through here, I could turn it on and off, and so on and so forth. But all in all, it's a good solution. The other way to go is to go ACI, which is the full managed SDN solution. And we'll probably talk about that in one of these sessions there, but that's where you don't even care about this at all there. You just focus on the SDN fabric, and you don't actually care about the Vxlans and whatnot. The solution takes 100% of it over for you, or takes care of it for you, I meant to say. So with that, I think we're pretty close. I was going to show you VPCs, but if the... see, this is pinging now. I was going to show you VPCs, but if Multicast is acting up... here, let me just try one last time to fix it there, because if I can, I'll show you VPCs. If not, I'll show you it next time. But you can see there that the ingress replication works just fine, which is the... taking the multicast out of the equation. So what we're going to do is we're just going to say no feature PIM. And this is going to remove all the PIM commands. So if I look at, say, the interface here, all that stuff's gone. So we're just going to say feature PIM. We want BSR to be listened to and forwarded. We want it on our interfaces. And we want it on our loopback. And then the spine is going to be our BSR. And we're not going to worry about priority. And the RP candidate will be for this whole range. So if I go here, show IP PIM neighbor, show IP PIM RP, we've learned it. And then the last thing we're going to try is we're just going to put this back to VLAN 123. just for fun, we're going to say that this is 1, 2, 3, 1, 2, 3. All right, so okay, so that's working. No, this is more of a platform thing. I'm not really too concerned about the dupes at the moment because this is a virtual lab. But I'm just happy it's working now. Yeah, see, it's just sorting itself out now. It's working fine. But anyway, this is what I meant to do before we took all that detour. So, yay me, I guess. But what we'll do is we'll just finish our verification here, and then we'll wrap it up with a quick VPC conversation. So now we see that we are learning all our MAC addresses. I'm going to try this command again. L2 route all. Oh, you know what? That's a VPC command. Never mind, I'm jumping ahead of myself. So the idea about VPC is that ordinarily we used to do this in the traditional network. We would have a switch, and then we would have a server, and we would do a port channel between it so that we have redundancy in case something happened there. And then when we had stacking, what we would do is we would put the first switch in the stack in one port and another switch in the stack in the other port there, so that we had a multi-chassis redundancy. So if one switch went down, we still had uplinks there. But in this paradigm, what we actually have is we have our leaf 1 and our leaf 2, and then we have our server. So if we want redundancy, we still want to be able to do this, but because they're two different switches with two different control planes, we need a feature called virtual port channel. And all the fancy stuff aside, all this really does is it tricks the downstream device to think that this is one device, and it does that by setting its LACP ID to be the same on both switches there, so that the server can't tell the difference, or the switch or whatever connecting into it. So what we do is we set up a peer link between these two servers, and this will let it sync the control plane information. And then we also have a keep alive so that the other server or other Nexus knows that it's still alive. And once this is all in sync, it's going to carry this down into there. Now with the Vxlan, this is a shared fabric. So this adds some complexity that we need to adjust for because it messes with the forwarding there. Because when we send the IP addresses for the EVPN or whatnot there, it can't really tell it apart there, so we need to change how the EVPN is configured so that this works. But this also enables some other features there. So for example, if we don't want to have a physical port link or peer link anymore, we don't need it. So let's try and keep this simple, or as simple as this kind of topic can get. And what we're going to do is we're going to go back to our CML. And all we're going to do is we're going to add two ports here for our peer link. And then we're going to use my management network as the keep alive. So we turn this on with, you guessed it, a feature. And no, I have not tested this beforehand there, so this could be a complete disaster, but, you know, we're having fun here. Feature VPC.
On Friday, they would be able to tell the difference.
Nice. Alright. So the first thing we do is we define our keep alive. And we do that by creating a VPC domain. And we just pick a number, so I have to say 100. And then what we want to do is we want to go peer keep alive, destination. And I have management IPs already set up on these switches. So that is 1020 to 224. Source is going to be 1020 to 223. And VRF is management. So that's good enough for right now. And then we're just going to say, do the same thing over here. We're going to go VPC Domain 100. And this destination would be 3, and this source would be 4. So if I go show VPC, you can see that the keep alive is working, but we have nothing else configured. So what we're going to do is we're just going to create a port channel. So we're going to say that in port 7 and 8, this is going to be a trunk. And this is going to be port channel group OACP. And then all we do is under a port channel, we say that this is a keep alive. Like so. And we do the same thing over here. We're just going to say 78 MTU 1500 because it complained. Put the trunk on. Channel group 1. So now our peer link is coming up. If we check over here, looks like it's coming. Is this having problems platform, or is this doing it? Show port channel summary. Okay, it's up. By the way, Nexus is port channels at E for channels, so that will bug you if you try and do it there, but just keep in mind that's what it is. So if I go show VPC, JCC is formed, peers alive. But what it's saying here is that the secondary IP is not matching there, and that's because with the Vxlan fabric, it needs a second IP so it can modify its next hop stuff. So this is what I'm not quite sure if it's actually going to work or not, but we'll give it a try. But we're going to say NVI1 shut. And then we're going to go loopback 0, IP address is going to be 32 secondary, because we're adding a second IP on the interface. But you haven't seen that in a while, Keith.
Indeed, I haven't.
And we're going to turn this back on. Actually, I'm going to get this guy going first. So we're just going to say shut. And we'll go back over here. We'll say no shut. Someone say something?
I was asking if you specify secondary on the
Nope. Oops. Shut. Alright, so I'm not entirely sure if this is going to work on this lab, but we'll see what happens in a minute. Okay, it did work. Cool. So what we have here is that the fabric is working through it there. And we could actually choose to take away the peer link, but we'll talk about that a little bit here. But first what we're going to do is we're going to have a look at our BGP. And what you notice is that the next hop is now the secondary IP because of the shared control plane for the VPC. So it's changing the next hop automatically for us. Now we've got to do a couple other things for quality of life. The first thing we need to do under the NVE is we need to tell it that we're advertising the RMAC capability, and this is essentially just a way for VPC to identify the host better. And then under BGP, it tells us that we need to do this under our BGP as well. So we'll go router 65.123 like so, and we say advertise primary IP address. So now we do the same thing over here. So we're just going to go show CLI history.
Was there a login synchronous for Nexus? Because I could never find it.
Well, it's on by default in most cases, but line. No, but I don't think it's necessary actually. I don't remember ever seeing an asynchronous log on Nexus. Because I've noticed all my lines are, all the logs are showing up on next lines, not interrupting my typing. Alright, so if I go show VPC, so now we have the actual control plane. So if I go to switch 1 here, or switch 12, you can see here that I have, well, that's all management stuff. Do show IP, oh, it's down right now. Okay. So what we're going to do is just say these ports. And yes, if you go in between Nexus and iOS a lot, the differences will drive you nuts. But we're just going to say that this is a trunk. A trunk. And then we're going to say that channel group 1 or 10 mode active. Okay, so that should be ready to go. So the switch is trying to do LACP. So all we got to do here is go to our switch port, which is 6 in my case. We're going to say this is a switch port. This is switch 12. We're going to say that this is a trunk. And we're going to say that this is LACP. And then under the port channel, all we say is VPC 10 because we're just giving it a number. And I think that's actually off, so we're going to say no. No shut. And then under port channel 10, it's VPC 10. So what we should see in a minute is that if I go show VPC, it's like the, oh, there it is. So that's doing its thing after a minute. We can see that the VLANs are allowed there because they have to have the same VLANs on both sides. And if I go look, we now have a port channel. And if I click here and do a do show EFR channel summary. So one side's working, the other one isn't working yet. Just give that a minute. Oh, it's trying to come up. Okay. It's 5, 6. Go over here. So what we have here is kind of a combination of everything. We have our leaf and our leaf and our spine. We'll just draw one. This is our EVPN. And this is sharing everything. We also have a peer link here for right now. And then we also have a port channel to a switch. And it is advertising everything for the control plane so that we have our VPC for a shared thing there. So you can see all these pieces kind of tied together. And the last thing I'm going to do is I'm just going to push my luck a little bit further. And I'm going to say that we don't have these peer links anymore. Actually, no, that's probably good enough for what we need. We don't need to, we'll try it, whatever. Doesn't really matter. We'll go here and here. All right, so now we're going to try using the Vxlan fabric to get us to a virtual port link, or peer link, sorry. And we're going to do that by just creating a new loopback. And we'll call this 192.168.111/32. And we'll just call this VPC pure. And then we're just going to say default interface 7 and 8.
So this is getting rid of the pure link.
Yeah, we're going to use the Vxlan or the Vxlan fabric to do the pure link instead of the physical one.
What about the keep alive though?
The keep alive is still management, the management network, and we don't want to touch that.
Okay.
So what we're gonna say is Vpc Domain 10. Oh, not 10. By the way, Nexus is pretty good about giving you warnings if you type something silly. Basically give you like a, are you sure you want to do this? Because it's very forwarding focused.
Quick question on stacking on Nexus. They don't have stack-wise cables, right? So it's all stacked by...
Yeah, it's all VPC. Because the data center, they really don't like stacking because it's a single share control plane and it can lead to some complications.
Okay.
And they prefer to have it so that you don't have to deal with that.
I think that was one of the limitations of VSS, wasn't it?
Yep, VSS also is the Catalyst way of doing it. And they also have virtual stackwise now, which is an evolution. But basically, if they don't want... they don't really like anything that can cause them any grief, to put it like there. So they like very predictable failover stuff there. And that's why they like things like automation and stuff instead for data centers, because they'd rather just have like a single switch that they configure randomly rather than having to worry about what happens when the master switch goes down. So we're just going to say VPC domain. We'll start this over. And what we're going to say is virtual peer link destination. And this will be 112 source 111. And by default, it's going to set a DSCP of 56, and that's good enough for me, so I'm just going to go ahead and hit enter here. And then on the other side, because we've done most of the work, we should just be able to say no VPC domain 100, default int 7 and 8. And then we'll say VPC domain 100. After I have to make the interface, so 112. Virtual peer link destination is 111, source 112. So that should be okay. Let me check the other one. Okay, it didn't mess that up. You can see 56, like I said. And then what we do is go under here and make sure that this is still the peer link. And we make sure that this is still the peer link. I'm not entirely sure if this is going to work, but we'll see what happens here. Actually, there's one more thing I need to do. So I need to tell the leafs which ports are actually connected to the fabric. So what we do is we say port type, and we tell it it's fabric facing. And we do that for the other guys too. If you ever worked with fabric path, it's the same kind of idea where you would set the port type to be a fabric path forward instead. You can see that this is coming up. And if I look, I should be able to go show VPC. Keep alive is something I didn't create, so that's why it's not working. Okay, so let me add the keep alive back in. It was 224 source 223 Vrf management. And we'll go 3 and 4. Pure link is down. Give that a second.
Can you scroll back up there?
What's that?
Can you scroll back up there?
Mm-hmm.
Did you forget to set the VRF?
Oh, by default, it. I thought I added in here, but VRF management. By default, it uses the management VRF, so you don't need to specify it. But if I go to show. Is connected. Now this might not work because if you looked up here, it basically says that we have to do carving for the where did we find that? But anyway, you need to do some special carving on there, and I never tried this on the virtual platform, so I'm not entirely expecting this to work, but we'll try it. DI1 shut.
It's actually the first time I've seen class selector 7 used ever.
Oh, for that 56?
Yeah. I've always kind of wondered, they always say like networking for 6 and 7, but it's the first time I've actually seen it used.
Yep. So it's if nothing else in this little tray, that's one thing. If I go loop shut. Yeah, not entirely convinced this is going to work, but we'll finish this thought up. And let me just do... All right, well, I'm not going to waste too much time on this. This is more of a extra feature I thought would be neat. But basically, the idea here is that you can, in physical gear anyway, get this working through the fabric. I suspect that if I played around with this a little bit more, I'd find a workaround. I'd probably need to do more, actually do that VPC TCAM there. I'm just not willing to reboot the Nexuses right now.
So, auto recovery command, does that help out?
No, the auto recovery is for if the keep alive fails and it the roll goes from primary to secondary. It helps it put it back to the way it should be. That's a completely different
Yeah.
thing there. Yeah.
Okay.
But anyway, I don't want to drag this down too much there. This was more of a pushing my luck a little bit. But if it does work, it's not really going to help out any of you there unless you're doing a CCI data center lab. In which case, you probably should be using real gear for most of the stuff there. But the 9K image is pretty good. But yeah, so anyway, what we did here is we covered Vxlan. We talked about the spine leaf stuff. We talked about EVPN. We did some BGP. We did the whole bum traffic stuff. And went through a bunch of scenarios. So hopefully by the end of this, you should have a pretty good idea of what Vxlan is and why it's useful. Other than that, if anyone has any questions, otherwise we'll wrap it up.
Kind of related, more just like a Nexus general thing. I was going to ask about the CFS over IP and things like config sync, if that's still common.
Yes and no. So the thing about CFS is that if you use it, which is basically it's a shared fabric that makes the configuration in sync between the different nexuses. If you do use it, the recommendation is to use it for absolutely everything. Where you get into problems is that when you configure it for some things there and then some guy configures something traditionally, you can get into some logic errors and issues there. So if you do use it, you want to always use it. Unless it's like a feature like this that turns it on for you, like VPC. But I find that most people find it's not worth the hassle. They would rather do something like Ansible or something to make things consistent, or something like Data Center Network Manager. But it does work.
Now that's the CFS over IP or just the CFS? Because I thought there was a distinction, but
Same idea. It's basically the same answer for both. Yeah, it's just what services you're putting on it.
But doesn't stuff like the precision time protocol become like kind of more important as you get into the data center stuff?
It does, like because with the Nexus stuff there, it's all about the fastest time there. Like if you set up switches for the stock exchange, it's going to be Nexus there because they have ultra low latency.
3Ks or whatever.
Yeah, 3Ks and 9Ks, that kind of thing. But the CFS itself, if the feature enables it for you, you don't need to worry. If you're doing it independently for configuration syncing, then that's when you need to be a bit more careful.
Did they use config sync though when you get into like a big spine leaf, or is that just when you're doing like the two peers and like a simple VPC?
It depends. Like usually you'd use CFS and something like a 2-core kind of thing, like core, and you just want to keep them in sync. And then when you do like your VPC or whatnot, you're not having to add it. Because right now, if I add VLAN 101 here, and I need to also add it here, otherwise we're gonna have problems because the configuration needs to sync, or it needs to match. So the idea of using something like CFS for your syncing is that you push it and then it pushes it to your fabric members, which is fine. It's just you just got to make sure that you're always in that workflow there. Otherwise, you don't want to get out of sync there. Where like if you add something else here, like independently, this is not necessarily going to be added to the fabric configuration. So you get all kinds of inconsistencies there. So you always want to make sure you're doing the distribute if you're doing it this way.
Okay, I was just curious because I found that config sync to be really annoying to work with, and I can only imagine that it's stale.
Yeah, well, that's the point, right? Like, well, not the point, but it's there's better ways of handling it, but it is an option. Because basically what you do is you do like an Ansible playbook, for example, and then you would just say, hey, push VLAN 101, and then it would just push all to members. Or you would do network manager. So if we open up this guy again, like I would push the networks like or VLANs and whatnot this way. So I'll go ahead and say like, hey, add this network, and it would go ahead and push it to all the things in the fabric, so we don't need to worry about it. So
So those doing it by hand in DNA Center, basically.
yeah, well, in DNA Center you would use templates, same idea. But the idea of this kind of stuff is you're not really caring what the VLAN is. You're just you're trying to just use it as what's absolutely necessary. Ooh, excuse me. But yeah, it's that is basically the answer. CFS, probably not a great idea, but you can use it. Anything else?
Seems like at the end of the day, they just, as long as they're in sync, it didn't really matter how.
Yeah, exactly, right. So yeah, as long as you have some kind of methodology that's in sync there, because if I already tore it down, but if I had this back up, then what would happen is that it would let me scroll up more here. So here is basically saying like, hey, look, here's the active VLANs and everything's in sync, consistency and stuff. If I was to add like 102, basically it would say like, hey, I'm suspending 102 because I'm not seeing it on the peer, and it would basically give you a warning that it's not consistent anymore. And if that inconsistency is bad enough, it's going to cause issues. So we can go show VPC consistency parameters, and we can look at something like global. And what it's going to do, the peer is down right now, but because I took it down. But what you can do is you can compare all this different parameters there. So, for example, if loop guard is enabled on one and not on the other, it's going to cause an issue, and it's going to flag it as inconsistent there, and it might not let you do VPC. So anyway, long story short, you want to make sure you're being consistent one way or another.
Cool.
Anything else, guys?
Hey, Donald, thank you very much.
No worries.
Thanks a lot. Yeah, it's amazing. See all this tech.
All right,
Do you
guys.
have anything to say about Pope?
I mentioned it briefly, but in one of my tirades. But if we go to like Fabric here, or is it Fabric? If we go to the Fabric here, if I go in here, if I go add switches, what it's going to do is I can discover existing switches and add it in, or I can do POPE, which is power on auto provisioning. And this is basically a form of zero touch provisioning, but the idea here is you add all the serial numbers and whatnot, and essentially this will act as a DHCP server, and when it boots, it will bootstrap the device by pushing all the configuration that we defined here onto the switch, and that's how it gets its job done. Make sense?
Yeah.
Cool.
Yeah, it looks really nice. Never saw this one before. The Channel Network Manager.
Yeah, it's kind of out of it has its purpose. For the most part, this is for if you want to do Nexus but you don't want to do ACI. So this is basically the way of managing things, but it can do a lot of fairly neat stuff there. So like you make your templates and you push your configuration, and then once this sets up properly, it will let you configure a lot of what I did there, but it does it through like templates here. So if I go fabric settings, and like for example, if I picked LAN Classic, it will just give me basic options for how to configure the network, and then the idea here is just it pushes consistency, and it also pushes a bit more streamlined there, so I can pick what I want to as I need it, and I don't need to worry about command line as much. I still need to know what all the features do, but it helps keeps things consistent if I have like 100 switches or 1,000 switches. And once we get into the EVPN stuff we're talking about there, it will provision it for us. So like if I go back to add network here, if I go add, I can just pick what I need to pick, and then like for VLANs, I can just say pick one, I don't really care, pick the next one. I can say generate IP, and it will basically it'll handle all the IP stuff for us there. So it's basically like a big IPAM, and it will keep in track of our VNIs and such. So I will probably, I don't know, if I feel like it, depending on what we're talking about in a couple weeks, I might circle back and show you how to manage it for the GUI. But otherwise, we'll see what Kelvin and I end up talking about.
Was that a Java app before? Because I thought I used like a really old one to talk to the MDSs.
The MDS age, yeah, that would be Java. That was it Storage Manager?
Something like that, yeah. Like showed you like a picture of the switch and the ports and stuff. It's really crude looking though.
Yeah, it's come a long way for what it is. Like this gives you like at least a nice topology, so you can see how things look, and you can right click not on this page, but you can draw what you need to, and it works pretty well for what it is.
Is it an unreasonable license cost, or sorry, not on, or a reasonable license cost?
Yep. It's one of those things there where they're not necessarily trying to make money off you there. It's more of a quality of life tool. I think the licensing, I haven't sold this in a while, but yeah, basically when you buy an Nexus switch, they're usually, depending on what tier you buy there, you typically get some kind of license that you can add in, just like you get for Prime Infrastructure. And then you can add it in there. So you can see like the trial is 50 free licenses, and then the actual price, you have to talk to your VAR, of course, but it's if you're buying a ton of Nexus switches there, this cost would be negligible, because if you're spending like if you're buying like 50 to 100 grand per switch, there a couple grand for management is kind of a non-conversation.
Yeah, you were saying what, $25,000 per end, and it's like 50,000
per GBIC for each SMP.
Yeah, no, that's crazy.
So, it's crazy, but at the same time, if you actually need 400 gigs of traffic or higher, then it's necessary, right?
Oh yeah, no, like that's piddly compared to what the use would be, for sure.
Yeah. And you can imagine if you're paying those kind of links there, how much downtime will cost.
It's on the scale of like taking a toothbrush to the moon or something. It's like 50 grand kind of thing per like gram of weight or whatever, right? Yeah.
It would be, those horror stories where they always say like, oh, the CEO's screaming that we're losing $1 million a minute. Those are the kind of environments where you'd have that kind of bandwidth. But anyway, yeah, it's a cool tool. I think I'll wrap it up here. But otherwise, Calvin, do you know what you're talking about next week? Are you talking next week? All right, we'll figure it out. Or by we, I mean him, because this is probably.
Did Calvin change his mic? He sounds different.
My headphones are dead, so yeah, I did change my mic.
Oh, wow.
Okay.
Sounds good. Yeah.
Yeah,
Well, as good as he sounds. All right, guys. Well, under here, if I didn't boomer this, I recorded this. So I'll throw this stream on YouTube for a change, so we can, you guys can check it out on my channel if you guys want to see what we went over. I'm not going to bother editing it, so go from there.
Cool.
All right,
It's
guys.
kind of fun watching that all the software end of things, because otherwise I never see it. Right?
Yeah, well, that's kind of the point of this. There, it's for one, it's hopefully to help show like the real world end of what Keith talks about, and also kind of show you that there's a lot else out there. So you guys can say like, hey, that data center stuff looks neat. Maybe I want to focus on that track, or
Yeah, service fire stuff looks cool.
the what?
Service
But
provider.
Oh.
Yeah.
You got to get a better mic if you got to tell jokes, man.
There we go.
All right, guys, I'll end it here. Talk to you guys as I see you, and I'll upload this. And I don't know how long this will take to upload, but it'll be up in a little bit, and we'll just have it as is.
Thanks a lot. Yeah.
All right, guys.
I was here for the start. I was sitting on the Anchor exam myself, and it was my third attempt, and I passed it today. So thanks so
good.
much for all the guys' enthusiasm. And
Oh, sorry. What was that? The Encore?
yeah, the Anchor.
Oh, nice.
I had third in last month, but yeah, I passed it this time.
So are you CCNP now, or do you have a specialization you got to do?
I have to pick a specialization, and I was always shouting from the rooftop I'm gonna do an RC, but the SD1 specialization looks kind of cheerful as well, so I have to rest my
Yeah.
mind on this.
Well, I'll definitely be doing SD-WAN stuff in one of these demos if I haven't. And I think, Keith, you made a SD-WAN course, or you're making one? Something like that? Anyway, it'll be covered eventually, so I hope you can have fun with that.
I have my CCNA in a week today.
Oh, nice.
Oh, congrats.
You got it. I've seen you do your labs. You're fine.
You got this, man.
Yeah, I need to do some Boson testing this week. Do some of you have some tips for like the last days before exam?
Ask the exam.
Yeah, every day.